I'd like to start by introducing my colleague, Bruce Rabkin, who's joining this second part of the morning or afternoon for you. Bruce, do you want to say hi?
Hello, everybody, and thank you for allowing me to join in for this part of the meeting.
Okay. I'm thinking that maybe I'll turn the video off so you can hear me better. Is that a good idea, or can you hear me fine as it is?
I can hear you fine.
Okay, let me know if I need to turn the video off. I'm going to be looking at this other screen to share the slides. So the title of my talk today is Recent Developments in Conceptualizing the Measurement and Estimation of Response Shift Effects. I'd like to start by acknowledging my colleague Bruce, who's joined us this afternoon or morning, depending on where you are. And also my other collaborators in the work that I'm going to be presenting, Roland Stark, Wes Michael, Yulin Lee, and Brian Stuckey. So I start with a cartoon that sort of expresses what many of us do for a living, asking people to quantify how they feel, no matter how hard it is for them. And I'd like to start by sharing an item that's a very common item in quality of life research, the general health item in the short form 36. Looks pretty straightforward. How do you rate your current health? But there's a lot of ambiguity. What does health mean to different people at different times? Rate in comparison to what standard? What time frame does current represent? Do these terms mean the same thing to different people? Are the numerical intervals used to quantify differences in quality of life actually equal? So this ambiguity led to work started about 25 years ago with Miriam Sprongers and myself to define response shift. It's the idea that a change in the meaning of one's self-evaluation of a target construct is a result of a change in the respondent's internal standards of measurement or recalibration, a change in the respondent's values or reprioritization, or a change in a redefinition of the target construct or reconceptualization. So I'll be referring to these as the 3 R's. And just to give you a sort of qualitative feel for what we're talking about, you could imagine someone telling you that they're moderately fatigued on a 5-point scale at one time, and then they undergo radiation treatment for cancer. Fatigue completely is a different experience then, and they tell you that they're moderately fatigued at the second time point. And so you can see these 2 4s don't mean the same thing. An example of reprioritization is given by Stephen Hawking, who says or said, I accept that there are some things I can't do, but mostly they're things I don't particularly want to do anyway. An example of reconceptualization is given by Christopher Reeve, who said he once thought a hero was someone who commits a courageous action without considering the consequences. But then after his spinal cord injury said, now I think a hero is an ordinary individual who finds the strength to persevere and endure in spite of overwhelming obstacles. So when we first started response shift research, there were basically 2 approaches for measuring response shift: factor analysis and the Venn test. And now there's a lot more options. We've really created an international initiative through the International Society for Quality of Life Research to study response shift, to develop, further develop theory, develop methods, and we have a lot more options now. I will be talking today primarily about the appraisal methods that we've been developing. And you can see that the interest in the field has grown over time. At this point, we have about 1,000 empirical papers on response shift, or they're not, some of them are focusing on response shift in the discussion, but they are all, they all come up with a keyword response shift. So theory is very important for developing the area. When we started, we had created a theoretical model that looked like this. A health state change, which was called a catalyst, would lead to response shifts that would be an interacting with stable characteristics of the individual, which we called antecedents, and cognitive, behavioral, and affective processes of the individual, which we called mechanisms. Those two would interact to lead to response shifts, which were, again, the 3 R's: change in internal standards or recalibration, change in values or reprioritization, or change in conceptualization or reconceptualization. And that would lead to perceived quality of life as measured. And this was a good starting point for a theory, but it had problems of circularity. Response shift was measured in ways that were very similar to mechanisms, so you had a hard time distinguishing these parts of the model. And also it did not distinguish between expected and observed quality of life, which was in fact the paradox that motivated response shift research. So Bruce and I came up with a new version of the theory that brought in the concepts of appraisal, and it infers response shift when changes in appraisal explain the discrepancy between expected and observed quality of life scores. So that idea of working with a discrepancy we operationalized as working with residual modeling. So we save residuals from a standard quality of life model and analyze those residuals in subsequent models. So in this approach, each dependent variable in your study would go through a standard model regression, dividing its information into 2 parts: the portion that's explainable by antecedents, like age, employment status, marital status, disability status, etc., and the part that's not explained by those variables. Those are the residuals, and that's the observed minus expected. So the part that is explainable translates to expected quality of life, and you could talk about those findings in terms of high expected quality of life, average expected quality of life, low expected quality of life. And the residual part is better than expected, the same as expected, or worse than expected. So appraisal can explain quality of life in cross-sectional models, and it can explain changes in appraisal can explain changes in quality of life after a catalyst. That is what we're calling response shift. So I'll make a very strong statement. There is no quality of life without appraisal. Individuals must consider what quality of life means to them, what experiences they've had that are relevant to quality of life, how experiences compare to desired circumstances or outcomes, and the relative importance of different experiences. So let's just translate that back to the 3 R's. Recalibration is about standards of comparison. Reprioritization is about sampling of experience and combinatory algorithm, or the relative salience of experiences. And reconceptualization is about frame of reference. So for example, to operationalize a reprioritization, it's necessary to measure the person's priorities at time 1 and at time 2 to observe if there's a change. So I think a helpful analogy to thinking about appraisal is the following, suggested by a spine surgeon that I've been working with for about, 12 or 13 years now, Joel Finkelstein. He says that response shift is the phenotype that's expressed by the genotype cognitive appraisal. To understand how a person measures their quality of life, we need to understand what they value and prioritize and how they calibrate a change. These appraisal processes are not static and are affected by environmental cues, life changes, and shifting perspectives. We can use this understanding of the individual's cognitive processes to improve patient outcomes. So the way we've expressed this in our work is as a contingent true score. That true quality of life score at time t is contingent upon the individual's frame of reference, which is right here, the ways that he or she identified and sampled relevant experiences, the reference group and standards considered in evaluating experiences, and the relative importance of each experience. A difference in any of these parameters yields a different true score. So we've developed measures of appraisal since 2004, and I'm going to describe to you very briefly a series of results from a number of studies. And basically, the appraisal measures have been eating up error variance since 2004. So when we started, we had the quality of life appraisal profile. That was a measure that had open text variable questions asking people to define their quality of life and goal-related concerns. There were face valid scales about cognitive processes, and in total it was 37 items. Then a number of years later, we developed the quality of life appraisal profile, which was developed after we did a lot of number crunching of the data from the QualApp V1. And it was a series of 86 close-ended questions. And then because everyone wants short measures, we created the brief appraisal inventory, which was derived from patterns of QualApp V2 factors. So it was from a second order analysis of the data, and we had 23 items in that. So just to give you a sense of what we're talking about, frame of reference is the content of individuals' concerns. Standards of comparison is the cornerstone of self-evaluation. Sampling of experiences is about retention, recall, and relevance. And combinatory algorithm is about patterns of emphasis. So how does one work with appraisal data? Well, with the QualApp V1, we coded a lot of open text data, and the themes that we coded them into were derived from content analysis with adjudication among judges. Just to give you an example of something that we did with that version of the measure, the then test is a measure that's often used for response shift assessment, and I've been doing methodological research on the then test for a long time. It basically asked at the post-test for people to retrospectively evaluate how they were doing on a particular question at the pre-test. And then the difference between the then test and the pre-test is called the response shift effect. So what does it actually measure? We did, we gave these open text questions to people and asked them to explain their then test discrepancy, and found that only 15% of the utterances actually reflected recalibration. So this was sort of a major nail in the coffin for me for the then test method. The other nail was how it was clearly confounded with recall bias. So I don't use the then test method for anything now other than maybe as a discrepancy score. A second way we work with appraisal data is item level analysis within domain. And my little buddy here asks, what do you get out of it, Doc? Do you guys have Bugs Bunny in other countries? He's familiar, okay? Good, I was worried about that. So we used, for example, item level analyses to look at the base rate for appraisal changes over time, because you can't really interpret change if you don't know how much change happens even in the context of stability. So we looked at chronically ill patients characterized by symptom change or stability in symptoms over a 6-month period. And we found stability in this group in frame of reference, standards of comparison, and combinatory algorithm, but a flux in experience sampling. So we concluded that the contingent true score was largely based on similar appraisal within individuals in stable versus unstable patient groups. So it's a way of getting a handle on the contingent true score in your sample. It's pretty useful. What can appraisal tell us about clinically important change? Well, it explained more variance in global rating of change scores than changes in PROs did. So this image I chose because it's a picture of a woman looking in a mirror. It's a Picasso painting. And what she sees in the mirror is not what she looks like. And that's sort of what we're talking about when we're asking people to rate their symptoms. There were people who maximized their symptoms. They tended to focus on disease-related experiences and emphasizing big changes. And people who minimized their symptoms tended not to recall recent experiences, focused on living situation goals, and emphasized long-term concerns. So another way that we work with appraisal is with principal components analysis to summarize information within domains. And when we did that, we were able to work in the context of structural equation modeling to look at mediation effects. And we found that appraisal was an important mediator of resilience to chronic illness, treatment burden, the alchemy of caregiving, in other words, turning a negative situation into something positive, and depression, but only for depressed individuals. So appraisal helps to capture the impact of life events. We found in another study that appraisal was more sensitive to catalysts than were item response theory or classical test theory based measures. So it's very relevant to interpreting such measures over time. So even with excellent psychometric measures, response shifts can occur. So now we have a fourth version, which I'm going to talk about. The first one, the Qualit V1, was a very good start, but it was really a lot of work to code the open text data. The second one, the 86 item version, is too long for most people to use. The third one is short enough for people to use, but I personally don't like it because it doesn't operationalize for appraisal processes in a very direct way. They're all reflected in the 23 items, but it's not as theoretically driven as the Qualit V2. V2. So we developed the Qualit V2 short form, and I'm going to talk to you about idiometric validation to enable selection of short form variants. That version has about 28 items. So that brings me to the sort of describing a path of emerging distinctions over this 20 years of studying appraisal. So the first thing I would like to share is about structure. Appraisal items explain variance across many studies and many patient populations, but the item intercorrelations and principal components analysis structure are not similar or not consistent across patient populations. So for example, improve my health and resolve problems with my healthcare load on the same factor in a general population, but on separate factors in a chronic illness population. This is what it looks like, just one table from a paper that we published recently. The table is intercorrelations of items within the standards of comparison domain, and the conditional formatting is done to show the magnitude of the correlations using Cohen's effect sizes as a metric. So the more saturated the color, the larger the effect size. And we have 6 patient groups here: spine surgery, multiple sclerosis, chronic illness, heterogeneous cancer, bladder cancer, and HIV. And you can see that the intercorrelations are different in the different groups. Some are more similar than others, and some are more different than others. The second thing that I'd like to point out is the issue of internal consistency. In the appraisal measures, the alpha reliability is not high enough to be what we would call psychometric. There's variability in internal consistency at baseline versus follow-up versus change scores. This is what this looks like. Here are alpha reliability coefficients at baseline, follow-up, and the change score for psychometric measures from the NeuroQual and PROMIS, and also the RIF psychological well-being measure. And you can see that they are more or less in lockstep. This is the alpha reliability coefficients for the QualApp V2. It's much lower, and they're not in lockstep. A third point that I would like to point out is that the goal of item development is different. The nature of appraisal item development is different from that with psychometric tools. It's not aimed at measuring an underlying latent variable, and it's not seeking item sets that are unidimensional or normally distributed scores. So I guess the best analogy is we're trying to sample this broad universe of desired content by sampling within each content domain a relatively short list that explains a substantial amount of variance in individual differences. And that led to an epiphany, and this is my favorite slide. Appraisal is not a psychometric animal. So it led us to develop a new typology of tools. There's psychometric and clinometric, which I'm sure you're familiar, and then there's idiometric, which I'm going to introduce you to. So there are theoretical distinctions among the tools. The goal is different. Psychometric tools aim to measure an underlying latent variable. Clinometric tools aim to identify a clinical phenomenon. And idiometric tools aim to measure a broad universe of desired content that explains individual differences. The desired item characteristics are different. Psychometric tools aim to have unidimensional and normally distributed items. Clinometric aim for clinically relevant items. And idiometric aims to sample relevant multidimensional concepts. The underlying latent dimensions may be contingent on external variables like diagnosis, setting, demographics. And then there's the effect versus causal indicator distinction. Psychometric measures are effect indicators, and clinometric measures are causal. And this is what I mean by that. If we're seeking to measure a latent variable like quality of life, a psychometric tool has items or subscales that reflect that construct. In contrast, a clinometric and idiometric tools, both of them, have items that are causal indicators. In other words, what they're measuring impact the latent variable and not the other way around per se. And the reason that's important is because you can't use the same statistical methods for a psychometric tool or an effect indicator as with a causal indicator. So the statistical implications are that you would use different data reduction techniques. For psychometric, you'd use factor analysis. For clinometric and idiometric, you'd use principal components analysis, where you're just trying to summarize as much variance as possible. Idiometric would include lower eigenvalues if it meant explaining enough more variance to matter. Indicators of reliability are somewhat similar across the three. You want them to be stable when health status is not changed, but psychometric would focus on internal consistency, and idiometric and clinometric would focus on, idiometric would allow structural instability if it was potentially meaningful. For example, different populations with different circumstances would have different internal consistency coefficients. The relationships among the items would differ as a function of those demographic or disease-related characteristics. Indicators of cross-sectional validity are somewhat similar. Face, content, and ecological validity are relevant for all three, but psychometric measures would focus on construct and discriminant validity. We would also expect to have a generalizable factor structure across populations, whereas for clinometric and idiometric, there would be an expectation of some similar structure, but idiometric would also enable or would also expect to have unique components across populations. That would be how it reflects how external variables are influencing the measure's meaning. For all three types of measures, indicators of longitudinal validity would be the same: stability in the absence of clinically important change, responsiveness to clinically important change. And they would have somewhat distinct clinical applications. What the psychometric would be more of a monitor or screen for providing better patient-doctor communication. Clinometric would be used as a tool for discussion and also a screen. And they can all be used as a way of intervening. So how do these distinctions impact how one validates an idiometric measure? Well, you'd be focusing on explained variance. You'd be looking at cross-sectional scores, explained variance in cross-sectional scores, in change over time, and the explanatory power of individual difference variables like age, gender, region, comorbidities, financial strain, employment status. And you'd be looking at the interaction of appraisal with those variables. And then tally the results in terms of Cohen's effect sizes. So to show you what we did to create the QualApp V2 short form, we did a number of MANOVA models looking at explained variance at baseline and at time, change over time, and looked at the explained variance, and then basically selected items that explained a decent amount of variance. If they didn't explain variance, they wouldn't be kept in the short form. So in this example, most of the goal delineation items worked well and did what we wanted them to do. And so one difference with an idiometric approach is that you're basically giving the end user the option to choose the best items that fit the content area of their work, rather than just saying these are the best short form items. So the QualApp V2 short form that we created, that I'm showing you here, that's just an example. It's 28 items, so it's sort of within that good short form number. It's got 6 goals that sample a broad range of areas, 4 sampling experience, then all of the combinatory algorithm questions, and all of the standards of comparison questions. We could have chosen fewer, but in the studies that we're working with, we thought that all of these were relevant. The measure is available in 6 languages, and I'd be happy to have you use it in any of your work. I just want to say that it's the 86 item version that was translated into all these items, into all these languages. So whatever short form ends up fitting your study can be created very easily. And the measure is currently being used in studies of COVID resilience in the US and Italy, experience of caregivers of children with multiple handicaps in France, response shift after spinal surgery at hospitals in Canada and the US, and to develop genuine doctor-patient partnerships in a New York healthcare system-wide initiative based on what matters to you, which many of you may be familiar with. It's an international movement in trying to improve doctor-patient communication and relationships. Thank you.